Okay, we're on 7.6 day 1 notes, and we're going to be actually solving these things now. So, very basic. To solve this thing, I need to do the L to get it into log form. So when I do the L, it becomes log base 4, 11 equals x. Now, your calculator's in base 10, but let me show you how to plug this in your calculator. We can do this thing called change of base to kind of trick our calculator into plugging it in the right way. Base change in your calculator looks a little something like this. You do log and then the big one, big font one. So log 11 divided by log 4. They each get a log, and that should be whatever you get out. So when I plug it in, I do log 11, close the parenthesis, divided by log 4, and I get 1.73. So x equals 1.73. Same thing with this one. So it becomes log base 8, 915 equals x. So to plug that in, I do log 915 divided by log 8. Log 915 divided by log 8 gets me 3.27 for x. Okay, now some more advanced ones. We're going to do a couple multi-step ones, kind of. So I'm going to add 15 first. Gives me 38. Now when I go to do the L part, becomes log base 3, 38 equals x plus 1. Plug this in your calculator. Log 38 divided by log 3 becomes 3.31 equals x plus 1. So when I subtract 1, I get x equals 2.31. Next one, subtract 32. 2 to the power of x minus 6 equals, that should get you 46. Then when I go and do the L, log base 2, 46 equals x minus 6. Make this into that decimal that you want. Log 2 gives me 5.52 equals x minus 6. Add 6, so I get 11.52. Subtract 2 first, 10 to the power of x equals 163. Then when I go to do my L, it becomes log base 10, 163 equals x. Now remember, your calculator is in base 10, so you actually just have to type in log 163, x equals 2.21. Here we got an E, so when I add 25, what's that, 170? So when I go to do this, I have log base E, 170 equals x plus 7. Remember, log base E is just natural log. Log base E and natural log are the same thing. So now I go and plug in, there we go, ln 170 gives me 5.13 equals x plus 7. Subtract 7, and I get x equals negative 1.86. So there's some actual solving ones. A couple word problem ones, and then we'll be done. The polar bear population in the western Hudson Bay of Canada has been declining at a rate of 1.32% per year. In 2013, there were 850 polar bears in the area. Write a model. So we're going back to the way beginning of chapter 7 for writing our model. It is started with 850, 1 minus 0.0132 to the power of t. T would be time in years. In what year was the population 1200? So we're trying to find out t if my final result is 1200. What's 1 minus 0.0132? 0.9868. There we go. Now to solve this thing, I need to get the exponent part by itself. So I'm going to divide by 850. So I have 0.9868 to the power of t equals 1200 divided by 850 gives me 1.41. So now when I go to solve this, I kind of switch that to the other side anyway so that I can do the L log 0.9868 of 1.41 equals t. So then I do my change of base. Log 1.41 divided by log 0.9868 gives me negative 25.86. So it was 26 years ago, about 26 years ago, that the polar bear population was 1,200. In what year will the polar bear population drop to 810? So 810 equals 850.9868 power t. Again, we're going to solve this thing, so 0.9868 t equals, and I divide it by 850, hopefully. 810 divided by 850 gives me 0.953. So when I go to do the L, 0.9868 of 0.953 equals t. Change base of that thing, log 0.953 divided by log 0.9868 gives me 3.6 years. So in about 3 years, 3.5 years, our population will drop to 810. One last one before we go. Subtract 10 first. 5 to the power of 2x equals 205. And then when I do my L, I got log base 5, 205 equals 2x. So then when I do this, log 205 divided by log 5 gives me 3.307 equals 2x, and divide by 2, and get x equals 1.65.